Hello dear students, just I am continuing the exercise 13.2. At the previous class we have completed up to the questions 10, just finding derivatives. Okay, now question 11 of exercise 13.2. So here find the derivative of the functions just given as sin x into cos x, sec x and 5 sec x plus 4 cos x. So first of all, just note down, we know that these are the formula as you can read. What? Sin, cos, tan. Whenever we get this. So here in the second question, sec x, find derivative of sec x. So this we have to find by which formula? By using first principle method. It is based on the given questions. Whether the question is long questions, then you can suppose that we have to find derivatives by using first principle only. If short question, then you can use direct method. Direct use this as a formula. So here, just see first question. 11 first. Let fx equals to sin x into cos x. Here we see that sin x into cos x, the product of two functions. So product rule can be used if we know these two as a formula. If we don't know, then just for this you have to find derivatives first of these two by using first principle method. That is just for finding derivative of this product. So f dash x equals to dy dx fx. So we can write dy dx of sin x into cos x. Okay. Now using product rule, this is u, this is v. So sin x derivative into cos x, u dash into v plus u into v dash. Here we require derivative of sin x. That is this. What is this? Dy dx sin x. It means this, and cos x into cos x plus sin x dy dx cos x. If we know this as based on the question, whether this question is very long questions, then just you have to find derivative this by using first principle, also this by using first principle, and then use that value here. So if we know this, then we can write direct. Derivative of sin x is what? Cos x. So cos x into cos x plus here sin x into cos x minus sin x. We know. So we get what? Cos square x minus sin square x. So cos square x minus sin square x, we know from trigonometry. This is equals to what? Cos square x minus sin square x equals to cos 2x. Okay? Cos 2x. Cos 2x. So its derivative cos 2x. Here, just we use this. 2 marks questions, 1 marks question you can treat it. If long question, then just you have to find this two derivative separately by using first principle and then use here. Okay. Now second question is what? Sec x. So here we have to solve now, or we have to find derivative by using first principle of sec x. This formula we have to prove because this is for first time. Now derivative of sec x by using first principle method. So for that, for finding derivative of any function, just you have to write first fx equals to. So second question, let fx equals to sec x. Then by using first principle method, we get first principle method. We get what? F dash x dy dx fx equals to limit s tending to 0 x plus h minus fx upon h. So limit s tending to 0. Just we will use trigonometric formula here. Fx plus h, fx equal to sec x, fx plus h, sec x plus h, sec x plus h. Here sec x upon h. Just remember that in the case of finding limit, either cot x, tan x, cosec x, sec x, except sin x and cos x. If we are having just like tan, sec, cot, cosec, then convert it in terms of sin and cos form. So here sec, so write it in terms of sec can be written as 1 by cos. So either in sin or cos form you can convert first. So 1 by h is here. Now sec means 1 upon cos x plus h. We can write by trigonometry 1 by cos x. Sec equal to 1 by cos. Now take its LCM because now our process is what? Finding limit. So in this case just use 1 by h, take LCM. So taking LCM, cos x minus cos x plus h upon cos x plus h into cos x. Taking LCM, we are having this value Now h tending to 0 is here. So 1 by cos x can be taken outside. And here, just see that cos c minus cos d. We know a formula, cos c minus cos d. What formula? Cos c minus cos d equals to minus 2 sin c plus d by 2 sin c minus d by 2. Clear? So if we treat it as a c, it is as d, then we can get formula as, just write, limit h tending to 0, 1 upon h cos c minus cos d minus 2 sin c plus d by 2 sin c minus d by 2. C plus d by 2, c is this, d is this. So what? 2x plus h by 2. 2x plus h by 2. And c minus d, that is x minus h. So minus h by 2. Clear? C plus d by 2, c minus d by 2. Minus 2 sin c plus d by 2 sin c minus d by 2 upon cos x plus h into cos x. This. Now here we see that 1 by cos x, because it is cos x, so h tending to 0, so cos x can be taken outside of the limit. Now limit h tending to 0, distribute limit as limit h tending to 0 with sin the minus 2 also can be taken outside, minus 2. Okay. Then here see that also sin minus h by 2. So minus sin h by 2. So minus minus plus. 2 is outside. Okay. Now write only this value. Sin 2x plus h by cos x plus h, this upon this, by 2. Just after this line, we are writing here now. Here, cos x, 1 upon cos x. Now limit h tending to 0. 1 by cos x can be taken outside. Okay. Now here, see, minus minus plus, so sin 2x plus h by 2 upon cos x plus h into sin limit h tending to 0 sin h by 2 upon h by 2. Here these two can be taken to denominator in this denominator, because h is here, so 2 can be taken here, h by 2. So h by 2 is this. Limit h tending to 0, h and this 2. So h by 2. Sin h by 2 minus, already adjusted here. So sin h by 2 upon h by 2, h tending to 0. H tending to 0, that means h by 2 tending to also 0. So we can write here h by 2 tending to 0. Because h tending to 0, also h by 2 tending to 0. So this. So this limit we know 1. Here 1 by cos x. Now h can, now the value of h as a 0 can be right here, because we can get definite value. So sin 2x plus 0 by 2 upon cos x plus 0 into 1. So we get what? See here, 1 by cos x into sin x by cos x. Here 2 to cancel, sin x by cos x. So 1 by cos can be written sec x, 1 sin by cos can be written tan x. So dy dx of sec x is this. This is the formula. Sec x, dy dx fx means sec x. Derivative of sec x into tan x. Sec x into tan x. So this is second question. Okay. Now question third. Five sec x plus 4 cos x. Okay. Question third. So now these are 4 we can use as a formula. Also you can use this as a formula. It will based on your question length. Okay. So here question 11 third. Let fx equals to, what is given? 5 sec x plus 4 cos x. 5 sec x plus 4 cos x. Okay. So derivative of sec x and derivative of cos x you can find from first principle method. Okay. If this question is of 1 or 2 marks, then you can directly use this formula. Or if this is long question, then you have to do its derivative and its derivative. That is this and this. First find by using first principle method and then use. We have already done it. So if long question, then you have to do separately, because if fx equal to this, then f dash x equals to dy dx fx. That is dy dx of 5 sec x plus 4 cos x. And this can be written as dy dx 5 sec x plus 4 dy dx 4 cos x. Algebra of derivative. So here constant can be taken outside. So dy dx sec x plus dy dx cos x. Now if this question is long question, then just you have to separately do it by first principle. I also separately do it by first principle and then write value here. If short question, then you can use as a formula sec x, that is 5 into sec x tan x plus 4 into cos x means minus sin x. So final answer is what? 5 sec x tan x minus 4 cos x. Okay, as a short question you can do up to now, and if long questions then just do it by using first principle method. Okay, here cosec x, so just cosec x. Now we have to find cosec x by using first principle method. So similar, we know that what is the procedure for finding basic formulas by using first principle method. Just convert trigonometric ratios first, either in terms of sine or cos, because we have formula related to sine and cos. So here cosec x. So question is what? 4. Let fx equals to cosec x. Then by using first principle method, we get first principle method f dash x, that is what? Dy dx of fx, limit s tending to 0 fx plus h minus fx upon h. This is our main formula by first principle formula. And here we know cosec equal to 1 minus 1 by sine. So you have to convert in either sine in cos format. So here limit h tending to 0. Just write first value of function cosec x plus h minus cosec x upon h. So just do it as the same procedure as from previous question. What? 1 by h is here, and cosec can be written as 1 by sine x plus h minus cosec 1 by sine x. Now take LCM. 1 by h, just we can write taking LCM. So sin x minus sin x plus h, sin x plus h into sin x. So here limit s tending to 0 1 upon h. Now here also you can use any of the formula. Sin c minus sin d or sin a plus b formula you can also use here. Any formula which you can you want to use for use here. Just see sin c minus sin d formula, because in the previous question use cos A plus B, here sin A plus B also you can use. But just now we use sin C minus sin D. You know sin C minus sin D formula? 2 sin C minus sin D, that is 2 cos C plus D by 2 sin C minus D by 2. So here use that formula. The sin denominator will be like this, sin x plus h and sin x. Now sin C minus, this is sin C minus sin D. C is x, D is x plus h. So 2 cos C plus D by 2, C plus D by 2, C plus D by 2. C minus D by 2, sin C minus D by 2. That is x minus h by 2. C minus D by 2. Sin C minus sin D we can use. So here just see, just I am writing here in short. See here, this 1 by sin x can be taken outside, sin x, because h tending to 0, sin x can be taken outside. Now x minus x cancel, sin minus h by 2. So sin minus h by 2 means minus sin h by 2. So minus minus, so minus sign will be here, minus sign. So minus 1 by sin x outside. Now h, this 2, h by 2 can be written here. So sin h by 2 upon h by 2. We will write in 1 plus. Okay. So limit h tending to 0, sin x plus h is here, and sin x is here, and here cos 2x plus h by 2, this by this, and this 2 with h. Here we can write another limit h tending to 0, sin h by 2 upon h by 2. Here as h tending to 0, h by 2 also tending to 0. So this is our combination. This limit is 1. Here h can be put as a 0 here and here. So 0, that is sin x, 0, that is cos x. So we get what? After this line, we can write minus 1 upon sin x, this limit cos 2x plus 0 by 2 upon sin x plus 0 into 1. So, we are getting minus 1 by sin x cos x upon sin x. This is minus cosec x into cot x. So derivative of what? So this can be written as what? Minus cosec x cot x. That is d by dx of cosec x is equals to this. Okay, so this is formula cosec x. Cosec x minus cosec x cot x, minus cosec x cot x. So this is also as established as a formula. Okay, also was the question 4. Now question 5. Question 5. So we are left for finding derivative of cot x. Okay. So just up to this stage, we know this are as a formula. Also we can prove last. The first, just we are using first let fx equals to cot x. Let us first establish this formula. Okay, see how can we do it? Let this, then f dash x equals to d by dx cot x, limit you write fx okay. So h tending to 0, h clear, first principle method. So this can be written limit h tending to 0 fx plus h means cot x plus h minus upon h. Clear? So we know for finding derivatives by using limit, just we have to convert any of the trigonometric ratios in terms of either sine or cos. So here cot can be written as a cos by sine. So limit h tending to 0, 1 by h is here, and now we can write cot means cos x plus h upon sin x plus h minus cos x upon sin x. Okay, now take LCM. Limit s tending to 0, 1 upon h we can write sin x plus h sin x. Clear? Here sin x into cos x plus h minus cos x into sin x plus h. So sin a cos b minus cos a sin b. Sin a minus b formula is there. Clear? Sin a, suppose sin this cos sin. Sin a cos b minus cos a sin b. So sin a minus b formula. If this is a, this is b. So you can use here limit h tending to 0, 1 by h sin a minus b. A means x and b means x plus h. So it can be written like this. Sin a minus b, sin a minus b x plus h means after breaking you can write like this upon sin x plus h sin x. Okay, this. Now here we see that x minus x cancel. So just write one time another m h tending to 0, 1 by h sin minus h upon sin x plus h sin x. Okay, so it can be written like this: limit h tending to 0 1 upon sin x plus h sin x plus h sin h minus sin h. So minus sin h upon h. We can write minus sin h upon h, and also 1 upon sin x. Okay, there are three parts up to this. Just see here, after this line, 1 by sin x, last value because x, so we can take outside, limit s tending to 0, here 1 upon sin x plus h, and minus sign is there, so you can write minus 1 here. Okay, and second limit is limit s tending to 0 sin h by h. Now we know that its limit is 1, and here we can put 1 upon sin x, 1 upon sin x plus 0, 1. Its limit is 1. So here we get minus 1 by sin x into 1 by sin x. So that is minus 1 upon sin square x. 1 by sin is cos. So we can write minus 1 by sin square x minus cosec square x. So derivative of cot x is this. This is also proved by using first principle method. Cot x, derivative of cot x is minus cosec square x. Okay. Now, just 5, 6, 7 question of part of 11, question 11. We can solve. By using direct formula as a formula. This question 5, 11. Okay, so let what is given? 3 cot x plus 5 cosec x. 3 cot x plus 5 cosec x. Cot x plus 5 cosec x. So here you see that f dash x equals to dy dx of fx dy dx of 3 cot x plus 5 cosec x. Okay, so this is equals to, by algebra of derivatives, we can write dy dx of 5 cosec x, and then as a constant 3 outside, dy dx cot x plus 5 outside, dy dx cosec x. So what? This 3, if this is long question, then you have to find derivative of cot and cosec by using first principle method separately, and then put value here. Cot x, that is minus cosec square x plus 5 cosec x means minus cosec x cot x. So this is the answer. So you can write like this: minus 3 cosec square x minus 5 cosec x cot x. Okay, now question. Five sin x minus 6 cos x. Question 6. This was the answer, the previous question. Okay. Now question 6. 5 sin minus 6 cos. 5 sin x minus 6 cos x plus 7. That is here 5 sin x minus 6 cos x plus 7. Clear? So here also derivative of sin and cos is required. So sin and cos, if long question, then you have to do it by first principle method, otherwise you can use direct. So dy dx of 5 sin x minus dy dx of 6 cos x plus dy dx of 7. So here as a constant outside sin x, as a constant outside 6, dy dx is cos x, or here 0. You know the derivative of constant is 0. So this. Now if we know it value, then you can write direct. If long question, then you have to do it by separately by first principle method. So sin x, derivative of sin x is cos x minus cos x is minus sin x. So here 5 cos x plus 6 sin x. 5 cos x plus 6 sin x. Okay. So the last question, 2 tan x minus 7 sec x. So similar, as a similar process, question 7 of 11. That is what? 2 10x minus 7 sec x. 2 10x minus 7 sec x. So 2 10x minus 7 sec x. Same process, because here 10 here sec, here 10 here sec. If long question, then find separately by using first principle method. Otherwise, in short question you can use direct. So dy dx 2 10x minus dy dx 7 sec x. Just use algebra. Here 2 outside. So dy dx 10x minus 7 dy dx sec x. Okay. So here 2. If long question, then just find these two by using first principle and then use. And direct, just write sec square x minus 7 sec x 10x. Use this formula. So this is the answer. Okay. So this complete the exercise 13.2. Okay. Just find limit or exercise, supplementary exercise for limit there was one more question, that is one minus so I will discuss miscellaneous exercise and some special limits finding in the next class. So do this derivatives, for finding these derivatives by using first principle method. Practice first principle method for different questions also, because this is important. And finding limit, also try to find limit of different type of questions by using reference book also. Okay, in the next class I will discuss about miscellaneous questions of this chapter. Okay, so send me 2-3 solution for your attendance related to this derivatives, trigonometric derivatives. Okay.